In this question we're going to look at functions. The diagram below shows the graph of the function f of x equals x cubed minus 5x squared plus 3x minus 2, where x is an element of the real numbers. Okay, the first part of this question, A part I, find the coordinates of the point at which the graph cuts the y-axis. So as you can see, this is the y-axis here, and it only cuts the y-axis at one point. So we want to try and figure out at what point does it actually cut the y-axis. Okay, the way that we do that is we know that all along the y-axis, if you pick any point on the y-axis, the x part of that coordinate is equal to 0. So all along the y-axis, x equals 0. So in order to find the x-intercept, or where the graph cuts the y-axis, the y-intercept, where the graph cuts the y-axis, we let x equal 0. So f of x equals x cubed minus 5x squared plus 3x minus 2. Okay, now for the purpose of this question, we're letting x equal 0. So the input is going to be equal to 0. So wherever we have an x, we're going to put 0. Okay, so where the graph cuts the y-axis is actually equal to minus 2. So as a coordinate, the x part is 0 and the y part is minus 2. Okay, it says, hence find f of 4 and f of 4.5, and hence explain the significance of your answers. Okay, so when we're looking for f of 4, all that means is the input of the function is going to be 4. So ever we have an x here in our function, f of x, where the x normally is, we're going to put a 4. Okay, so f of x equals x cubed minus 5x squared plus 3x minus 2. Okay, remind ourselves that ever we have an x, we're going to put 4. So we have, as you can see, 4 is in the bracket where x was. So 4 cubed minus 5 times 4 squared plus 3 times 4 minus 2. And if we put that into our calculator, we will get minus 6. Okay, similarly enough, when we are trying to find f of 4.5, everywhere we have an x in our original function, we're going to put 4.5. So we have 4.5 cubed minus 5 times 4.5 squared plus 3 times 4.5 minus 2. Okay, again we can put this straight into our calculator, and so our answer is 1.375. Okay, the significance, it says explain the significance of your answer. So as you can see, when x is 4, the output, or y, is equal to minus 6. Okay, when x is 4.5, y is equal to 1.7. Okay, so putting that into perspective, we'll say for example, this is 4 and this is 4.5. Okay, sorry, this is 4 and this is 4.5. Okay, what that actually means is the input changes from 4 to 4.5 and the output changes from positive to negative. Okay, so it goes from negative on the y-axis to positive on the y-axis, which means between these 2 points the graph cuts the x-axis. Okay, so between x equals 4 and x equals 4.5, the graph cuts the x-axis, or we can find the x-intercept between those 2 points. Okay, on the far page we are looking here at finding the derivative f dash x, the derivative of f of x. Okay, so we know that f of x, so we're going to start by doing that and then we'll find out the second part afterwards. Okay, so f of x from our original question is x cubed minus 5x squared plus 3x minus 2. Okay, to find the derivative, we multiply by the power and reduce the power by 1. Okay, and that's the given rule. So we multiply by the power, so multiplying by the power 3x and then reduce the power by 1. Multiply by the power and reduce the power by 1. Okay, and the same goes for this. Multiply by the power, 2 times minus 5 is minus 10, and reduce the power by 1, so 2 goes to 1. So just x to the power of 1, or just x. 3x differentiated is 3, and any constant differentiated is 0. So now it says find the coordinates of the local minimum turning point of the function. Okay, so when we find, just to draw a quick sketch for you, as you can see, this is a quadratic function. Okay, it's a happy quadratic function because the x squared term is positive. Okay, so the turning point is basically this point here, where the graph changes from negative to positive. Okay, and it's at this point we can see that if we make a line, a tangent to the curve at this point, the slope of that line is actually 0. It's not increasing or decreasing. Okay, and when we differentiate a function, we find the slope of the tangent to the curve at a given point. Okay, so when that point is equal to 0, that is our minimum turning point. Okay, so we have differentiated it, and so in order to find the turning point, we're going to let f dash x equal 0, because the slope of the tangent to the curve at this point, at the minimum point, should be equal to 0. So we're going to solve this equation for 0. So 3x squared minus 10x plus 3 equals 0. As you can see again here, this is a quadratic, so we're going to solve it like so. Opening up your brackets, 3x at the start of the first bracket and x at the start of the second bracket, because 3x times x is 3x squared. Factors of 3 that will give us 10x. So we're going to put 1 in here and 3 in here. Okay. When we multiply inside by inside, we get 1x, and outside by outside, we get 9x. Okay, and we want a minus 10x, which means both of our signs need to be negative, like so. Okay, then we can solve here for x. Okay, so now we have 3x equals 1, so x equals a half, and add 3 here to both sides, so x equals 3. Okay, the derivative function of this function is quadratic, but the original function is actually a cubic function, which means it goes something like this. Okay, which means there's actually 2 turning points. So the turning point here, we need to find the corresponding y values, so it's asking for coordinates. Okay, now as you can see from the original function, the minimum point is the highest x value. So the smallest x value is the maximum point. The largest x value is the minimum point. Okay. So the largest x value is going to be this one. Okay, so that's our minimum turning point. So to find our corresponding y value, we're going to sub in 3 to the original function. Okay, and we get 3 cubed minus 5 times 3 squared plus 3 times 3 minus 2. Okay, and when we put that into our calculator, we will get minus 11. So our minimum point is 3 minus 11.